you to part 4 of the program on Islam and Science with Dr. Noah Aydin, Department of Mathematics and Statistics at Kenyon College in Ohio. My name is Dr. Gerald Grutson. I teach religion and science courses for San Jose City College and Global Ministries University. I'm very happy to be here to moderate this session with Dr. Aydin, and I'll turn it over now to Dr. Aydin.
Thank you, Dr. Grutson, and thank you everyone for joining us this evening. Okay, so this is the fourth lecture in the series. So let's briefly recall what we talked about last time. We talked about two narratives of history of science, particularly in regards to history of Islamic science. We talked about the common narrative that we call the classical narrative and compared and contrasted it with the alternative narrative. We also talked about the role of Imam Ghazali in Islamic science, in the history of Islamic science and the Golden Age. And we looked at the nature of the debate between Imam Ghazali and Muslim philosophers. So today, we are going to talk about some specific examples of actual contributions of Islamic scholars, medieval Islamic scholars, to mathematics and other sciences. And we are going to see the influence of some of these Islamic scholars on European Renaissance. And we are going to provide concrete evidence against many of the claims of the classical narrative based on research on primary sources in the last few decades. So I also would like to share with you some resources that we just produced this summer, freshly produced set of sources very much related to what I'm going to be talking about today. And these resources should be useful to anyone who is interested in this topic, particularly teachers and researchers. So let me show you. So one of my students this summer worked on this project to produce. So this page here under Kenyon College, Digital Kenyon, gives a description of the project. And then at the end, there are links to the digital materials that we produced. So there are two sets of materials. One is digital stories, which are short videos on various topics about Islamic contributions to math and sciences. And the second set of materials is some animations and illustrations of certain topics in mathematics from medieval Islamic scholars. So we hope that these materials will be useful for people who are interested, particularly teachers who can use these in classroom. So I encourage you to check out these materials on this link. And I will be talking about some of these topics today. But of course, I won't have time to talk about every one of them. So this is a permanent source of materials for you. Speaking of time, I also would like to remind you that today's presentation may last a little longer, but hopefully next week's presentation may be a little shorter. So we'll see how it goes. Okay, so remember, one of the assumptions of the classical narrative is that, in terms of origin of science, it is the brilliant Greeks, that we owe the origins of science. And, according to this narrative, which is, more based on prejudice and ideology rather than actual research on primary sources, the source of brilliance in science is Greeks. Of course, Greek science was indeed brilliant, but the problem is it is brilliance in science, according to this narrative, is exclusively, belongs to Greeks, and any other civilization, in particular the Islamic civilization, is like inferior, secondary to Greeks. So unfortunately, that has been a common view. Here are a couple of quotes from some of the most influential Western philosophers, right? So these are not just isolated ideas or thoughts or quotes. These philosophers, by and large, shaped much of the Western intellectual history and approach to history of science. And we can easily see their influence at many different levels. Even though there has been progress in changing this narrative, it is still pretty much the common narrative, which is widespread, not only in the West, but even in the Muslim world. So according to this narrative, the main role of Islamic civilization was that of a fridge to preserve the brilliant Greek science, right? That is the main role of Islamic civilization. But if you look at the actual materials, is it really the case? Well, here are a couple of books written by Islamic scholars, Muslim scholars. So here is Abu Bakr al-Razi, one of the famous physicians of the Islamic civilization. So he wrote a book titled Kitab al-Shukuk ala Jalinus, which means, the translation is Doubts on Galen. Okay, what is this? What is this book about? Doubts on Galen. Why did he write such a book? Well, he wrote a whole book on problems with Galen, right? So why did he write such a book? Well, because Islamic scholars went well beyond just translating and preserving Greek science. They were highly critical of the information that they found in Greek texts. So as much as they had a great respect for Greek scholars, but when they found problems in their works, they did not shy away from criticizing them. Okay, in the next generation, here is another book by Ibn al-Haytham, another great Islamic scholar, Shukuk ala Batlamius, which means doubts concerning Ptolemy. So this time, Galen was the Greek expert in medicine from the Greek tradition. And similarly, Ptolemy was the most important astronomer of the Greek tradition. But here we go. Ibn al-Haytham is criticizing Ptolemy. Why is he doing that? Because Ibn al-Haytham and other Islamic scholars found a lot of problems in Ptolemy's astronomy. Everything from simple arithmetic calculations to mistakes in astronomical observations to more serious problems, foundational problems, in terms of the inconsistency between Ptolemy's basic cosmological principles and assumptions and his mathematical models on papers. And Islamic scholars, Ibn al-Haytham and many other Islamic scholars said, no, we cannot accept such inconsistency between basic principles and their representations on paper. And they started this whole tradition of reforming Ptolemy's astronomy. And they started this Shukuk tradition, which was about reforming Greek science. So in this same book, Ibn al-Haytham, so here is a quote from Ibn al-Haytham from this book, Doubts Concerning Ptolemy, which shows his approach and attitude towards scientific inquiry. He says, if your goal is to find the truth, which it should be, right, for any scientist, then you must submit to the argument and demonstration, not to the sayings of any human being, no matter how famous they might be, right? So he says, you must be very critical of everything that you read. So look, this is the mind of a true truth seeker, a probing mind. How critical, he's being to the knowledge he's inheriting from the giants, right? From the giants of science and scholar, in particular Greek scholars. So this was the attitude they brought to examining the Greek science. This is way beyond simply blindly following and preserving them. So again, Muslim scholars, as much as they respected Ptolemy and other Greek scientists, they were at the same time highly critical of them, only because they found a lot of problems and errors and mistakes in their works. So they started this tradition that is called the Shkuk tradition, which is about addressing the issues that are found in their texts. And this tradition yielded some very interesting results that we are going to look at now. So you know this guy? Who is this? This is, of course, the famous Copernicus, who is one of the icons of Renaissance, right, and scientific revolution. And with his work, he did start a revolution. However, the way we learn about Copernicus, and typically the way the kids learn about it in school, is that he started a revolution, like a sudden revolution, and we are not told anything about the connections between Copernicus and earlier Islamic scholars, even though now it's been many, many decades since we learned about these connections. So things started with modern researchers' discoveries about connections between Copernicus and earlier Islamic scholars. So here's a paper from 1957, you see, 1957. So more than 60 years it has been. So look at the title of this paper, The Solar and Lunar Theory of Ibn al-Shatir, a pre-Copernican Copernican model, okay, written by Victor Roberts, who was a student of Edward Kennedy, who was a prominent historian of Islamic science. What is this paper about? Well, the purpose of this paper is to present the solar and lunar theory developed by the Damascene astronomer Ibn al-Shatir, who lived in 14th century. And the interesting thing about this is that his model, lunar model, and later on they discovered that even more astronomical models were not just similar but identical to the models that were used by Copernicus, who came like 2 centuries after him. So Copernicus, instead of using brilliant Greek science, he decided to use the more recent Islamic science by Ibn al-Shatir. So if the root of everything is Greek science, so why is it that Copernicus is using Ibn Shatir rather than Ptolemy? Well, of course, the answer is pretty straightforward, because Islamic scholars updated Greek science a great deal, and they came up with much more useful and accurate astronomical models. Now, a couple decades later, another interesting discovery and connections were discovered by modern researchers of science. So here is a paper by Willy Hartner, who was one of the most prominent historians of science at the time, who was the president of International Academy of History of Sciences. And here is the title of his work, his paper, Copernicus, the Man, the Work, and its History, written and presented in 1973. Okay, so Hartner discovered something really remarkable about Copernicus. He found that Copernicus, in addition to using the astronomical models of Ibn Shatir, he also used a mathematical theorem called 2C couple, who was introduced by another Islamic scholar, al-Tusi, even earlier than Ibn Shatir. So al-Tusi, so this is actually known as the 2C couple theorem in the literature. And so it turns out that Copernicus stated and proved very same theorem without referring to anyone, Tusi or any other person. And even more striking thing was that even the labeling of the points in the geometric figure was identical. Whenever Tusi used the Arabic alif to denote a point in the geometric figure, Tusi used the corresponding letter A. Where Tusi used the Arabic letter ba, Copernicus used the letter B, and so forth. So there was even a one-to-one correspondence in the labeling of the points in the geometric figure in the proof of this theorem. So based on this evidence, Hartner came to the conclusion that Copernicus must have been aware of Tusi's work, because this just cannot be coincidence, right? So again, this theorem, the 2C couple theorem, was first proposed by Tusi in 1247 and then formally proven in 1259. So this is what, 3 centuries. This is 3 centuries before Copernicus, and we have the complete, we have the original document where Tusi actually does it, and Copernicus simply states and proves the same theorem, and even the labeling is the same. However, there is no reference to any earlier scholar about it. So Tusi's theorem is about generating linear motion out of 2 circular motion, and this was part of the project to fix the problems in Ptolemy's astronomy. Remember the Shkuk tradition? So it was in the context of this project that Tusi came up with a new mathematical theorem, and that result was used by several Muslim mathematicians and astronomers to refine and reform Ptolemy's models. So Ibn Shatir used it, Urdi used it, and other scholars used it, and eventually Copernicus himself also used it, both directly and indirectly. So there are several points in these discoveries by modern researchers that disprove the classical narrative. So for one thing, all of these scholars, Tusi, Urdi, and Ibn Shatir, all came after al-Ghazali and also after Mongol invasion of Baghdad. So remember, according to classical narrative, Imam Ghazali or Mongol invasion of Baghdad, they were supposed to end the golden age of Islamic, progress in scientific activities. But these scholars lived well after both of these events. And interestingly, it was the same Tusi who convinced Hulagu Khan, who destroyed Baghdad, to build an observatory just the next year, the year after Mongol invasion of Baghdad. He convinced the same ruler to build this observatory, which was the most advanced observatory to that date. And that observatory played a crucial role in the research in astronomy that was eventually used by Copernicus, right? So classical narrative would never tell you about these events, right? So And the other point to refute the classical narrative is that Ibn al-Shatir and al-Tusi, they were also religious figures. And to many people, they were actually primarily religious scholars who did, scientific work as a side activity. But of course, they were first-class mathematicians and astronomers at the same time. So there are like so many points here to refute the claims or assumptions and or teachings of the classical narrative here. Unfortunately, you don't hear these things in the typical representation of Islamic science or history of science. On the other hand, those scholars who actually studied original materials, both Copernicus and Islamic scholars, they came to this conclusion, right? So they view Copernicus as a continuation of the tradition of research in astronomy in the Muslim world. You see, this is a very different conclusion and representation of Copernicus. See, look, the point here is that this is not to say that Copernicus did not do important work. He did. However, he did not do things out of blue. He was connected to Islamic scholars more than he was connected to the Greek scientific tradition. So the problem is that those connections to Islamic scholars, they are simply not taught, And not only they are not taught, most people still don't know about them, even though it's been so many decades after these connections have been established by researchers based on primary source research. Here is another example from medicine. So, typically pulmonary blood circulation, discovery of that is typically attributed to William Harvey. I verified this with my friends who are physicians. I think this is a typical teaching. However, researchers found that it was an earlier Islamic scholar by the name Ibn Nafis who lived, 4 centuries before William Harvey, who actually proposed it, right? So his Ibn Nafis manuscript came to the attention of modern researchers in 1920s. And so here, just like many other Islamic scholars, Ibn Nafis is saying that Galen, remember the Galen being the Greek authority on medicine, Ibn Nafis is saying that Galen says such and such, but it does not really make sense to us, and he proposes his own explanation. You see, this is going well beyond just simply imitating and preserving Greek science. Islamic scholars are improving it. See, this is exactly how science progresses. So you learn the state of the art up to that point, and there is usually shortcomings or errors or mistakes in the current knowledge, and you try to improve it. This is precisely what Islamic scholars did. They learned what Greek scientists did, and whenever they found problems, they improved upon them. They went beyond what Greeks did. However, the classical narrative mindset would say, oh, none of Galen's errors could be corrected, they would claim, you see? So this is one of the classical books on classical narrative. So this is the assumption they are making, right? Which is objectively not true. Okay, so here is another great Islamic scientist, Ibn al-Haytham. So according to Jim al-Khalili, who's a physics professor in England, is the greatest physicist in the 2,000 year span between Archimedes and Newton. He is known as the father of optics because he was the first scholar who correctly understood how we see things, and he also discovered the properties of light. So in his book of optics, Kitab al-Manazir, the book of optics, is considered to be the birth of optics. So he's known as father of optics, but his more important contribution to science was actually the methodology he used to prove his hypotheses about optics. So what he did was he used simple, repeatable experiments to prove his theories about optics. So in this regard, he should be considered as the pioneer of the modern scientific method, because he was probably the first major scholar in history who correctly understood the importance of experimentation in scientific investigations. Unfortunately, the later European scholars did not give him the credit of being the pioneer of the scientific method. Instead, the credit went to later European scholars as usual, So, so if you really put things in perspectives, the significance of Ibn al-Haytham in history of science is comparable to Archimedes and Newton. Unfortunately, his significance has been undervalued by this common narrative, the classical narrative. So we'll come back to some of his contributions. So that's why the subtitle First Scientist in this book, which I highly recommend. This is a popular book about Ibn al-Haytham, short, very easy to read book, a great introduction to the life and contributions of one of the greatest Islamic scholars. And there is also a well-known problem in the literature that is known as al-Haytham problem, al-Haytham being his Western version of his name. Okay, so today I would like to spend more time on contributions of Islamic scholars to mathematics, because this is my area of research. So let's look into their contributions in mathematics in some details. So let's start with the number system that we use today. Okay, what is it called? The numbers that we use today? Are they called Arabic numerals? Yes. Why are they called Arabic numerals? Because European scholars learned it from the Muslim scholars. So why not to use Roman numerals? Why to use Arabic numerals, right? We are supposed to be connected to Greeks, Greco-Roman heritage. Well, actually, Europeans stuck to Roman numerals for a long time, but eventually they switched to Arabic numerals. That's because, did you ever try to do arithmetic in Roman numerals? If you try to do it, it is possible, but it is much more cumbersome to do arithmetic in Roman numerals. I think that was one of the main reasons why they eventually switched to Arabic numerals. However, it is not accurate. It is actually misleading to call these numbers Arabic numerals, because even though Europeans learned them from the Islamic world, Muslim scholars never called them Arabic numerals. They always consistently and universally called them Indian numerals, because Muslim scholars learned it from Indian scholars. So here is a diagram showing the evolution of these numerals from India through Muslim world to the modern versions. By the way, one of the misconceptions about this topic is that, oh, you Muslims invented zero. No, Muslims did not invent zero. Zero was already in the system that Muslim scholars took from Indians. You know, zero was already there. However, zero was not regarded by a number by itself, though. It was simply a mark to denote the fact that a position is empty in representing a decimal number. You know, regarding zero as a number by itself is a more advanced, more abstract thought that occurred later. But I wanted to make the point that it is one of the misconceptions about Muslims' contributions to mathematics. You know, so this false information, like fake news, became very popular somehow, but the correct information is not known. The thing about this number system is that the system from Indians was only for whole numbers, integers. It did not include decimal fractions. So it turns out that a Muslim scholar, as far as we know, you know, based on best available research, it was a Muslim scholar who introduced the decimal point and decimal fractions to this number system. So his name was Abu Hassan Ahmed bin Ibrahim al-Uqdudisi. Now, al-Uqdudisi was his nickname, referring to Euclid, you know. So that's probably because he was probably making copies of Euclid's books. So he wrote a book on Kitab al-Fusul fi Hisab al-Hindi, you know, which means the book of chapters on Indian arithmetic. You see, as you can see here, Muslim scholars always refer to this number system as Indian numbers. So this book, there is a single manuscript copy of this book, which is located in Yeni Cami Library in Istanbul, Turkey, which happens to be my hometown. But unfortunately, this book was not studied by modern researchers until 1960s. By that time, incorrect information and assumptions about the source of the decimal point and decimal fraction became widespread. So I really don't want to go into details of how he discovered the decimal point, but it was really interesting. You know, it came out of the process of finding half of a number. So here is the first decimal point in history. It was a little vertical dash on top of a number to represent the unit's place. So here is the, you know, the digits 179685 in Arabic numerals or Indian numerals, and this mark simply denotes the unit's place, because it turns out that in the process of, you know, finding half of a number, al-Uqdudisi needed to introduce more digits, and he needed to mark the unit's digit. So this is the first decimal point in history, as far as we can tell, based on primary source materials. The Europeans, you know, learned about decimal fractions much later, and by the works of, due to Simon Stevens' book on decimal number system, written in late 16th century, for a long time, Stevens was considered to be the inventor of this number system. However, this all changed when a researcher noticed Miftah al-Hisab, a book written by an Islamic scholar, al-Kashi, more than a century before Simon Stevens. Miftah contained a full treatment, a systemic treatment of the decimal fractions. Because of this discovery, researchers assumed that al-Kashi was the inventor, and which turned out to be still incorrect. So you see, so researchers first knew about Simon Stevan, then they found al-Kashi's book, Miftah, but then, you see, look, they found Miftah in 1940s, they found al-Uqdudisi's book in 1960s. You know, they are going backward, so each time they are acquiring more accurate information. So clearly, there was a big lack of, lack of research on primary sources, and a lot of works from the medieval Islamic world were not studied. So, this fact compelled me to make a contribution to this field, and it compelled me to learn Arabic and to make available some of the important works in this field. So I decided to start a translation project to translate Miftah al-Hisab to English. So even though the content of Miftah has been known for a long time, it has never been fully translated to English, except for 2 short sections. So finally, it is being translated to English in 3 volumes. So the first volume is already available, and the second and third volumes will be coming soon. So the Miftah was one of the most important mathematics books of the Islamic civilization, but unfortunately, modern researchers were completely unaware of it until almost until the middle of 20th century, and because of that lack of research, a lot of misattributions were made about some topics in history of mathematics. And when I was working on this translation project, which which has been going for many years, I came across this book by Simon Stevan. I might have mentioned it in an earlier lecture. So here is a book published in 2008, 60 years after the fact, after researchers realized that Simon Stevan was not the inventor of the decimal fractions. Still, this book makes the claim that, Stevan was the author of the first textbook about decimal fractions, and this false information is repeated in the foreword of the book by a very highly educated person, a Nobel laureate in physics, Dr. Hooft. He repeats this false information in the foreword of this book. Look, this is 60 years after the fact that, after we realized that Stevan was not the inventor. So what is more striking about this is that the authors of this book, 2 university professors from Europe, they pretend to talk about the history of decimal fractions, but they leave out the most important figures in this discussion. They do not talk about al-Kashi and al-Uqdudisi. I mean, if they did not talk about this, it would have made more sense. But the fact that they pretend to talk about it, but leave out the most important figures, I don't know how to explain it, right? They claim that Stevan's, invention was a radical invention, an elegant way of representing decimal fractions, but the scholars who actually studied, who did research on primary sources, and you can also tell that Stevan's notation was really awkward, even though he wrote about decimal fractions more than 6 centuries after al-Uqdudisi. More than 6 centuries. It is not just a decade or 2, or a century or 2, more than 6 centuries, and still his notation was nowhere near as good as al-Uqdudisi. So again, okay, eventually researchers found the more accurate information about the history of decimal fractions. But the thing is, the sad fact is that it did not become common knowledge. See, it did not become common knowledge. So once false information becomes widespread, it is much harder to correct it. Still, very highly educated people are repeating this false information. So, this history of, decimal point and decimal fraction is a representative of the larger picture. You see, it is really telling. It is not an isolated example. It is telling, it is giving us a glimpse of what's going on in the broader narrative of history of science. So more examples. So what is the most important branch of modern mathematics? So I hope there are some math teachers and maybe math professors who are either watching this program now or will be watching it later. I think the answer is pretty clear, at least in my mind. It is algebra, right? So by algebra, we don't mean just the algebra that you learn in high school, even middle school, but it is one of the principal branches of modern mathematics. We call it abstract algebra or modern algebra. So not only is it one of the principal branches of modern mathematics, but it also influences literally every other subfield of modern mathematics. And here is a proof, right? Everything from algebraic geometry to algebraic number theory, algebraic coding theory, which happens to be my primary area of research. So basically, you can take any subfield of modern mathematics and stick the adjective algebraic in front of it, and there is such a subfield. So where does this algebra come from? What is the first algebra book in history? Well, algebra comes from the title of a book written by an Islamic scholar. When do you think it was written? Well, it was written in early 9th century, Kitab al-Jabr wal-Muqabala. So this is the first time algebra appears as a mathematical discipline. And in fact, the word algebra is a transliteration. See, not a translation, but transliteration of the Arabic word al-Jabr. So fortunately, we have this book available to us in English translation. You can buy this book. It is available. So what does al-Jabr mean in Arabic? Remember, Arabic is the root system. So jabara is the root here. Al is the definite article. So its dictionary meanings include setting broken bonds, restoring. Setting broken bonds is related to the idea of restoring, but it also is the meaning of forcing and compelling. What does that have to do with, technical mathematical meaning? So even though al-Khwarizmi did not give a formal definition for it, its meaning is restoring a quantity that is subtracted on one side of an equation, restoring it on the other side as a positive. So for example, in this equation here, 3x is subtracted on the left side of the equation. We restore it on the other side as positive, so that other side becomes 4x. Or we can also think of it as 3x is sitting on the wrong side. We force it to go to the correct side and as positive, right? So that is the operation of algebra. So transforming this equation from this form to this form is the operation of algebra. So by the way, the term algorithm comes from the al-Khwarizmi's own name, as you can easily verify from any dictionary, right? Al-Khwarizmi became algorithm, which is, of course, one of the major, most important notions of modern science, right? We cannot really do anything with computers without algorithms. So in this book, al-Khwarizmi explains his motivation to write this book. So here is the quote. He says he wanted to include what is subtle in calculation and what people need in their operations regarding inheritance, legacies, and commercial transactions, and surveying parcels of land, digging water channels, and so forth. So from this description, it may sound like that al-Khwarizmi was like an applied mathematician. But when we actually look at what he did in his book, the main thing he did in his book was the classification of quadratic equations. So he classified quadratic equations into 6 types. However, he never used symbols in his algebra. He did everything in words. It was purely a prose. His book is purely prose. And he said by using the operations of algebra and al-Muqabala, he showed that any quadratic equation can be put into one of these 6 types, and he showed how to solve each of these equations. Again, everything in words. So like he used the terms mul and numbers equal roots, which would be represented by this form in symbols. He used specific examples to solve classes of equations. He was probably the first person in history who gave recipes to solve classes of equations as opposed to individual equations. And Islamic scholars also use results from Greek geometry to verify their algorithms to solve quadratic equations. Again, I don't have time to go into the details, but in doing so, they synthesized Greek approach to math, which was purely geometric, with Indian approach that was numerical. They combined these two approaches to create a new science called algebra, which became so big in modern mathematics. Some people argue that, al-Khwarizmi was not the first person to consider quadratic equations, and he never used any symbols. Why should be considered as the originator of algebra? Well, that's because even though he did not use symbols, he introduced the idea of manipulating the unknown, even if it was in words. And he also classified equations and showed and provided recipes called algorithms to solve classes of equations. So these were novel ideas in his works that justify the idea that he was the pioneer in starting the field of algebra. So after al-Khwarizmi, many Islamic scholars worked on this discipline, which became a well-established discipline in mathematics. And of course, the Miftah, about 1/3 of Miftah is about algebra, and it will be the 3rd volume in our translation series. A later Islamic scholar actually gave a formal definition of algebra as operating on the unknowns using the same arithmetical tools in the same way that you would operate on the known quantities. Another important Islamic mathematician who worked on algebra was Ömer Khayyam. Ömer Khayyam is better known as a poet, right? I mean, you might have heard him as a poet, but he was also a first-class mathematician, and who contributed astronomy and geometry and algebra. And in particular, he worked on cubic equations. Just like al-Khwarizmi classified quadratic equations and showed how to solve them, Ömer Khayyam classified cubic equations and he showed how to solve them. And his book on algebra is available in English translation, and we have two different translations of it. So he took a geometric approach to solve cubic equations. Again, I don't have time to go into details of this. You can find more information about this in the videos on the website I showed you. Now, the important point I would like to highlight about his work in algebra is that he says in algebra, we have known and unknown quantities, and there are some relationships between them. He says our goal in algebra is to use these relationships and the rules of algebra to figure out the unknown quantities. And he also says it doesn't matter where these quantities and relations come from. It doesn't matter whether they are pure numbers or geometric quantities or anything else. That just doesn't matter. All that matters is that there are known and unknown quantities and relationships between them. You see, look, this point of view is really valuable. And that is the reason why algebra became so influential in modern mathematics. It doesn't matter what the context is. We can use the ideas of algebra in many different settings. It doesn't matter that the quantities are pure numbers or anything else. So this point of view was really valuable, and it became very big in modern mathematics. So he was not unlike al-Khwarizmi, he was not able to come up with a numerical recipe to solve cubic equations. And he admitted that, and he hoped that future mathematicians would be able to do that. And indeed, 4 centuries later, European mathematicians came up with an analog of the quadratic formula, which is for the cubic equations, which is a bit more complicated. Now, so back to Ibn al-Haytham. So calculus is one of the most beautiful and useful intellectual achievements of our intellectual history. That is indeed the case. And of course, beginning of calculus is attributed to Newton and Leibniz, which it is true that they made major contributions. And that's why, this book, The 100, Newton is number 2 in this list, and largely because his contributions to calculus, but also his achievement in optics alone. Michael Hart says Newton's achievement in optics alone would probably entitle him to a place on this list. But unfortunately, Michael Hart does not talk about the father of optics. You see, he's just completely ignores the father of optics or the experimental method. He gives the credit to Galileo and Newton and Kepler for the introduction of the scientific experimental method. Now, beyond that, researchers recently found that Islamic scholars and scholars from India had ideas of calculus. They did some calculus already, even though it was not in the most general form that Newton and Leibniz did. Nevertheless, here is a book, and there is also a paper. Oh yeah, here is a paper by Katz. Here is a book talking about the ideas of calculus in Islam and in India. And we also devoted one of the videos on the website to this topic. You can learn more about it. So look, people like, this is the common narrative. Yes, what Newton and Leibniz did was really great and important and significant, but that doesn't require us to ignore and overlook the contributions from Islamic civilization and Indian civilization and other civilizations, right? So it turns out that Ibn al-Haytham did calculus, in computing the volume of a paraboloid in the context of optics. he did what we call Riemann sums today, right? Riemann sums is calculus. So, and as a manifestation of this, there are many examples of misleadingly named mathematical facts or objects. Well, for example, Pascal's triangle. Well, it is attributed to Pascal, but it was around for a long time before Pascal, many centuries before him. Like in Iran, it is called Haytham triangle because Ömer Khayyam talked about it, but it probably has even more, earlier history as well. There's a theorem called in number theory called Wilson's theorem, which is attributed to Wilson, who neither stated nor proved the theorem. It was first stated by the same Ibn al-Haytham. So look, it was more than 7 centuries before Wilson that it was stated. And then there are other examples as well. Unfortunate misattributions. So again, in this presentation, I don't have time to go into more details, but in my course, we discuss these contributions by Islamic scholars in greater details. Achievements in arithmetic, in algebra, more detailed account of their attributions in geometry, in trigonometry. So after the works of Islamic scholars, trigonometry became a discipline in its own right, independent of astronomy, and they established the most basic facts about trigonometry, and really there was not much to be discovered in trigonometry after their works. So my specialty is mathematics and mathematical fields, but Islamic scholars contributed to, or in some cases created brand new disciplines of all fields of inquiry in their times, and even creating new disciplines. Definitely astronomy is a major discipline, but physics, chemistry, medicine was a major one, another major discipline, philosophy, geography, So as an indication of this, we have so many technical and scientific terms in English that come from Arabic. So many of them in all kinds of fields, right? All kinds of fields. And yet another manifest indication of this legacy is that many, if not most, of the star names are actually Arabic, right? Why is that? Because the significance and massive contributions of Islamic scholars to astronomy, right? There are just so many of these star names. So everything from decimal point to algorithms to scientific method, to optics, all of these are profound contributions, profound part, of modern science that will not become out of fashion. You see, some scientific facts or theories become out of fashion, but these, algorithms and algebra and the decimal number system are unlikely to go out of fashion in modern science for a long time. Similarly, scientific method. So all of these fields, we owe either the origin of these fields to Islamic scholars or major contributions to these ideas and disciplines or concepts from the Islamic civilization. So, what would modern science look like without these? But unfortunately, if you just learn what classical narrative tell you, you will be unaware of these fundamental contributions from the medieval Islamic civilization. So once again, I encourage you to check out this website to learn more about the specific contributions, especially in mathematics and mathematical disciplines like astronomy and physics and optics, but also also to learn more about the classical narrative versus the alternative narrative. So we just produced fresh set of materials to help spread the more accurate information on this topic based on primary source research rather than ideology and prejudice, which classical narrative is based on. So I will stop here. As I was anticipating, we took a little longer today, but hopefully next time, which will be the last session, it will be a little shorter next time. And this is the topic for next time, where we will talk about the age of decline in Islamic science and the lessons to learn from the history and our homework, So what lessons that we can learn from all of this research and what happened in history. So I would like to stop here, and if there are any questions, I will be happy to entertain them. Thank you.
Unless there's another question, I have a question. Do you think that the age of the Crusades had any impact on the, as you said, the improper assessment of Islamic science? Because the Western world grew apart from the Islamic civilization, even though it was indebted to it.
Yes.
The Crusades started in the end of the 11th century and continue for over 150 years. So that was my question.
Yes. I think Crusades did play a role, and actually an important role. For one thing, Europeans came into contact with Islamic civilization firsthand. They had the chance to observe firsthand, what Islamic civilization achieved, right? So, and it provided a direct contact with the Islamic world, and so they saw that there was an advanced civilization, and I think that led them to learn from the Muslim world. So, and of course, just like Islamic scholars learned everything from Greek sources, they translated all the works from Greeks. The reverse translation in the reverse direction happened a few centuries later from Arabic to Latin and European languages. And again, Crusades, created an opportunity for Europeans to observe the Islamic scholars the first hand, right? It brought Europeans into direct contact with the Islamic world. But on the other side of the coin, this mentality of Crusader mentality persisted for a long time, right? So it is behind this, this prejudice, this ideology is of course very much connected to Crusades, right? So viewing the Islamic world as the other, as the enemy, right? That mentality persisted for a long time. Even to this date, right? We can easily tell that, that it is still around. It is very much well and alive, even into 21st century, in one form or another. But the idea behind this, Islamic world is the other, is the enemy, is the inferior, right? So it played a dual role, So it is one of the lessons to learn, right?
Yeah. Huntington's book, The Clash of Civilizations, kind of popularized the idea of conflict between civilizations, whereas I think your presentation shows that the two civilizations, the Western and Islamic civilization and the Jewish Christian, were integrated quite well for many centuries.
So even though Crusades were literally a clash between two civilizations, but at the same time, it opened the door for exchange of ideas, right? Exchange of ideas. Yeah. So hopefully, right, we'll, going into future, we should really focus on the beneficial aspects of,
Right.
Looking at differences in civilizations.
Yeah. The UN has a program called the Alliance of Civilizations, which emphasizes how civilizations in different parts of the world need to collaborate around these main issues. We see that now with healthcare, how important with the pandemic. If we don't learn from each other and work together, the pandemic just keeps expanding.
So notice that, so regarding to this point, notice that Islamic scholars did not mind learning from Greeks or any other civilizations. Right. Even to the point, look, remember the debate between Imam Ghazali and Muslim philosophers? Even to the point of Muslim philosophers adopted the doctrines of Greek philosophers that are contrary to the Islamic beliefs, you see? Right. Look, this is a very critical point, right? So scholars did not mind learning from other civilizations. Similarly, European scholars did not mind learning from Islamic scholars, you see? Copernicus did not shy away from learning from Islamic scholars. So even though he did not explicitly state so, right? Copernicus and many other scholars learn from each other. So scholars, scientists always did that,
Unfortunately, ideology, as we know today, with certain failure to follow medical science, hurts us because people use ideology to try to counter science. And that's what's hurting us with the pandemic right now.
Yes, but at the same time, though, I would like to remember the quotes from the early, there are intellectuals and philosophers, influential, scholars and philosophers who did subscribe, unfortunately, this ideology that the Western world is superior, right? So it is not confined to lay people that the West and the East and Muslim world are different. Unfortunately, there have been intellectuals and philosophers who also, promoted and even, introduced this idea of the Western science, right? Greeks and, Europeans. So, yeah, we should not ignore the fact that there are those prejudices and ideologies among intellectual people as well.
Well, thank you, Dr. Aydin. This has been very helpful, and you've done some wonderful work, and you should be congratulated for the work you've done on the original sources. As an historian myself, I know how important it is to have access to the primary sources in order to have a true picture of the history of science. So thank you, and we'll look forward to the part 5 of your program. If you want to repeat it once more.
Yeah, my slide is up. So if you can let, if you can share my screen again. So
it's up there.
Yeah, I'm showing the topic and the questions for the next session. So I hope you can join us next week. So if not, recordings are available on YouTube. So good night, everyone, and see you next week. Please take care and stay well and healthy.
Thank you again, Dr. Aydin.
Okay, thank you.
All right.
Good night.
Good night.